Here is your Unit 2 test. And so we're going to go over your Unit 2 test. Hopefully this will help you kind of clear up some of the confusion you might have about Unit 2. You can expect to see questions like this in the multiple choice. And I can, again, almost guarantee that it's going to show up somewhere, somehow. And then possibly the free response. It's becoming a popular question for the free response section. Let's start with the multiple choice. The residuals plots from 5 different least squares regression lines are shown below. Which of the plots provides the strongest evidence that its regression line is an appropriate model for the data and is consistent with the assumptions required for inference for regression? So if you want your regression line to have an appropriate, be appropriate, then you want your regression model to show you pretty much nothing, no pattern at all. So if you're looking at these choices, here we have this U shape, here we have a upside down V. This one looks like it's kind of getting smaller. This one's getting larger. So C is the only one that has random scatter. Again, you want to see random scatter, so the correct answer is C. All right, number 2. The computer output below shows the results of a linear regression analysis for predicting the concentration of zinc. This is very important so you don't get the question backwards. In parts per million from the concentration of lead found in a fish from a certain river. That means we're going to have zinc hat equals, okay? And it says, which of the following statements is a correct interpretation of the value of 19 in the output? So here's the 19. Well, I'm going to go ahead and write the equation so that I know what I'm talking about. Again, the constant is your y-intercept, so zinc hat equals 16.3. And then lead is my x variable, so plus 19 times lead. Okay? I've got the concentration of zinc hat equals 16.3 plus 19 times lead. That means I'm talking about a slope. This 19 is the slope. So I'm reading through these answers. I need to make sure that I'm talking about the slope. So A says, on average, there is a predicted increase of 19 parts per million in concentration of lead for every increase of 1 parts per million in concentration of zinc found in the fish. That's very close. You want to say something about an increase of 1 for the lead to get an increase of 19 for the zinc. For every 1 unit of X. This has it for every 1 unit of zinc. That's for every 1 unit of Y. So that is backwards. On B, on average, there is a predicted increase of 19 parts per million in concentration of zinc for every increase of 1 parts per million in concentration of lead found in the fish. That is exactly what you're supposed to say for slope. For every 1x, there is an increase of 19 for y. Right? That's what you're trying to say. That's correct. Let's look at these other choices. The predicted concentration of zinc is 19 parts per million in fish with no concentration of lead. That means that lead equals 0. That would mean they're talking about the y-intercept, and the y-intercept is 16.3, so that's incorrect. D, the predicted concentration of lead is 19 parts per million in fish with no concentration of zinc. Again, that has the variables flip-flopped, so that's incorrect. And E, approximately 19% of the variability in zinc concentration is predicted by its linear relationship with lead concentration. This is a interpretation of R squared, and R squared is 82%, not 19%, so E is incorrect. Be careful with your wording. Number 3. The correlation between two scores, X and Y, equals 0.8. So R equals 0.8. If both the X scores and the Y scores are converted to Z scores, so we're standardizing everything, then the correlation between the Z scores for X and the Z scores for Y would be, if you standardize everything, the correlation is the exact same. So it would still be 0.8. There's no math involved. If you have a correlation of 0.8 and you standardize everything, the correlation is still 0.8. End of story. Number 4. Which of the following scatter plots could represent a data set with a correlation coefficient of r equals -1? This is a very strong, like we're talking the strongest it can get, negative correlation. So, A looks like it's very strong and negative. B is not linear, so can't have a correlation. C is very strong but positive, so that's not right. D doesn't really have a strong correlation. I mean, where do you draw your model? I don't know. And E has a very strong correlation, but it has a direction that is pretty much not positive or negative, so can't be E either. Okay? Had to be A. These are, again, questions from the actual exam. Don't miss the easy questions. All right, number 5. The equation of the least squares regression line for the points on the scatter plot below is y hat equals 1.3 plus 0.73x. What is the residual for the 0.47? A residual, again, is an actual data point the y value, minus the predicted data point, y value. So in this case, we use the y value. This is going to be 7 minus, then whatever we would get if we predicted with x of 4 in this equation. So 1.3 plus 0.73 times 4. Whatever we get that's predicted, that's going to be the difference. So if we do the math, 0.73 times 4 plus 1.3, that's 4.22. And so we do 7 minus 4.22, and we get 2.78. And so 2.78 is choice A. So again, a residual is the actual data point that you have minus the predicted data point, which you have to get by substituting x into your model. That one's kind of confusing, but that's how residuals work. All right, number 6. In a recent survey, 60 randomly selected married couples from the same town were asked to rate the overall quality of living in their town on a scale from 1, very poor, to 10, excellent, on 20 different attributes such as accessibility to major highways, yada, 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 yada. For each couple, the husband's individual ratings on the 20 attributes were averaged to produce an overall quality rating, and that process was repeated for the wife. Each point on the scatter plot below displays the overall rating of one of the 60 couples, with the husband's rating represented by the horizontal axis and the wife's rating represented by the vertical axis. So you have husband, wife, coordinates. It says, based on the scatter plot, which of the following statements is true? So we need to make sure we read through these very carefully. Sorry. Make sure we read through these very carefully so we make sure that we choose the right thing. And it's all about wording. Husbands tended to rate the quality of living higher than their wives did. So start looking at some points. This point, for example, is 4.3-ish, 2.1-ish. At that point, did the husband rate the quality of living higher than the wife? Yes. So pick another point. This point is 8.1-ish and 6-ish. Did the husband rate the quality of living higher than the wife did? Yes. So A is looking like it could be a legitimate answer. B, more overall ratings of 7 or less were assigned by husbands than by wives. Well, let's look at husbands. 7 or less. It's about that many. Okay, let's hear 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There's about 20, if I drew the line right there, ish, 20-ish. Okay, that's for husbands. Do the same thing for wives. 7 or less. Well, that's way more than 20. There's only like 4 above 7, right? So more overall ratings of 7 or less were assigned by wives than by husbands. Okay? So be careful. B can't be true. On C, the range in the husband's overall ratings is greater than the range in the wife's overall ratings. So again, range is the highest minus the lowest. So range for husbands is what? We'll say 9. Minus we'll say 4.5. So that's 4.5. And then the range for wives, the highest is about 8.5. Minus, we go all the way down here to like 2.5. So 8.5 minus 2.5 is 6. So the range in the husband's overall ratings is greater than the range in the wife's overall ratings. That is not true. Again, these are backwards. The range in the wives is greater than the husband's. It's all about wording. Be careful. Okay. D. The difference in overall ratings between a husband and wife was not more than 3 for any couple. If we look at our scatter plot, sorry, having some technical issues. There we go. Difference in overall ratings between a husband and wife was not more than 3 for any couple. Well, let's pick some couple. I don't know what this couple just sticks out to me. The husband's rating was 4.5. We'll say 4.5. The wife's rating is 2. So the difference is about 2.5, and it says was not more than 3 for any couple. So that one doesn't work. Let's pick one of these higher ones. All right, so that one, the husband had a rating of like 8, and the wife had a rating of about 7. Okay, that works. What about something in the middle? That one's 7, 6. Okay, so we keep looking. What about some of these outliers over here? This one has an 8 and like 3. Well, that's way different. So if you start looking over in this section, right, you're going to have differences of more than 3. So D can't be a choice either. And then E, for each couple, the overall rating assigned by the husband was the same as the overall rating assigned by the wife. Well, you can look at the points I just had. The ratings are not the exact same every single time. So E can't be a choice either. So A definitely was the right choice. It takes looking at the wording and kind of looking at the scatter plot, and this one might have taken a little bit longer, but you already had the residuals question on number 1 and the correlation question where you had to pick out the correlation of -1. Those should have taken no more than 20 seconds. So you save time on those two so you can spend more time on this one. All right, number 7. A least squares regression line was fitted to the weights in pounds versus age in months of a group of many young children. The equation of the line is weight hat equals 16.6 plus 0.65 age. A 20-month-old in this group has an actual weight of 25 pounds. Which of the following is the residual weight in pounds for this child? Again, this is a residuals question. The residual is the actual Y minus the predicted Y. So the actual weight in this case was 25 pounds. And then they defined the predicted weight. So the predicted weight, I would use the equation. So 16.6 plus 0.65 times the age in months, so 20-month-old. I would figure that out. So 0.65 times 20 plus 16.6, and 25 minus that answer. 25 minus this answer is negative 4.6. So the correct answer is B. An actual y minus predicted y. They give you an actual weight. That's why you go use the equation to find the predicted weight. All right, on number 8. All but one of the statements below contain a mistake. Which one could be true? This is all about correlation. So the correlation between height and weight is 0.568 inches per pound. Correlation has no units. Incorrect. The correlation between weight and length of foot is 0.488. Okay, that could be legitimate. You have two quantitative variables, so that could be okay. C, the correlation between the breed of a dog and its weight is 0.435. That is incorrect because breed is not a quantitative variable, it's categorical, so you can't calculate a correlation. D, the correlation between gender and age is negative 0.171. So that is incorrect because, again, gender is not a quantitative variable. And then E, if the correlation between blood alcohol level and reaction time is 0.73, then the correlation between reaction time and blood alcohol level is negative 0.73. Those would be exactly the same. So again, the correct answer had to be B. Number 9. The correlation coefficient between high school grade point average and college GPA is 0.56. That means R equals 0.56. For a student with a high school GPA that is 2.5 standard deviations above the mean, we would expect the student to have a college GPA that is R times that many standard deviations above the mean. So we have 0.56 times 2.5. 0.56 times 2.5, 1.4. So 1.4 standard deviations above the mean. And last multiple choice question. A small town employs 34 salaried non-union employees. Each employee receives an annual salary increase of between $500 and $2,000 based on performance review by the mayor's staff. Some employees are members of the mayor's political party and the rest are not. Students at local high school form two lists, A and B. One for the raises granted to employees who are in the mayor's party and the other for raises granted to employees who are not. They want to display a graph or graphs of the salary increases in the student newspaper that readers can use to judge whether the two groups of employees have been treated in a reasonably equitable manner. Which of the following displays is least likely to be useful to readers for this purpose? So you're getting a table, and you have raise, mayor staff, and raise non, or mayor's party, my bad, non-party. Okay, so if you're looking at that information, a back-to-back stem plot, that could be very useful in comparing the salaries and the raises. So that could be useful. A scatter plot. In a scatter plot, you have two different variables, which we do here, but are we looking for any sort of correlation or like increase or decrease or something? That might be kind of tricky, so we'll come back to that. Parallel box plots are great for comparing information, because that's what we're trying to do. Histograms drawn on the same scale, those are great for comparing information. Dot plots are great to compare information. So yeah, B ends up being the right answer. It's not going to be helpful to see a scatter plot that has raise for people that work for the party or part of that party, and then raise for non-party compared. That means you make a coordinate out of two things that don't really go together. So that's not really very helpful in making any comparison. Okay? So the correct answer is B. So there's your multiple choice. Some of them are more difficult than other. You definitely had to know residuals. You had to know how to use a regression equation. You had to know how to write an equation from a computer output. You had to be able to read a scatter plot, read a residuals plot. All those things came in handy. So let's look at the short answer. A philosophy professor has found a correlation of 0.8 between the number of hours students study for his exams and their exam performance. During the time he collected the data, students studied an average of 10 hours with a standard deviation of 2.5 hours and scored an average of 80 points with a standard deviation of 7.5 points. Create a linear model. That means we are going to write an equation. To estimate the number of points a student will score, that means we want to have score hat. We are estimating the score. On the next exam, from the number of hours a student studies, show your work. So in this case, score is Y and hours is X. That's very important. Now, they gave us the correlation and the means and standard deviations of all of the variables. Okay? So, in order to write the equations, we need to use the equations from the yellow formula sheet, AP formula sheet. Our slope equation says that we take R times the standard deviation of Y divided by the standard deviation of X. So if we show our work, R is 0.8 times the standard deviation of Y. Again, Y is score. And so scored an average of 80 points with a standard deviation of 7.5 points divided by the standard deviation of X, which is hours studied, which is 2.5. If you do that math, you get 2.4. So now I have the slope. I then need to find the y-intercept. That equation says that you take the average for y minus the slope times the average for x. So you have, again, average y is average score. So an average of an 80 on the test minus a slope of 2.4 times the average hour studies, which is 10, and then you get 56. So in writing the equation, you get score hat equals the y-intercept, 56, plus the slope, 2.4, times x, which is hours studied. That's exactly what you should have. All of the work and the equation in context. B, if a student studies for 15 hours, what score should the student expect on the next exam? That's just giving you an x value so you can make a prediction for y. So you're just substituting that into the equation. Score hat equals 56 plus 2.4 times 15. So my predicted score on the next exam would be 92. It's not too shabby. And then it says the student in part B above actually scored a 90 on the exam. Find the residual. Again, the residual is the actual minus the predicted. So we have an actual score of 90 minus a predicted score of 92. So the residual is -2. All right? That's how you do the first one. You have to be able to do that. You need to know how to use those formulas in case one comes up. All right, next page. According to the World Almanac and the Book of Facts 2004, the debt per capita for the years 1990 to 2001 gives the following scatter plot. So we can see we have debt year as X, and we have debt per capita for Y. That's important. A regression output gives the equation of the regression line as follows, and it gives you the equation, and it gives you R squared. So it says, what is the response variable? That is just vocabulary. Response variable means Y, and so the response variable is debt per capita, not that year. What is the correlation coefficient R? Well, they've given us R squared, and that's actually just algebraically R squared. So we rewrite it as a decimal instead of as a percentage. So R squared equals 0.988. And so R would be the square root of that, which is 0.994. Then we need to look at the scatter plot, and this is positive, so we leave it as a positive. If it had been negative, you would need to put a negative in front of it, because remember the slope of the scatter plot, or slope of the regression equation, has to match the correlation. So the sign needs to match. Explain in context what the slope of the line means. Well, the slope is the number in front of the variable year. So it means for every 1x, for every 1 year, for every year, the debt, whatever your y is, in this case it's positive, so increases by $1,128. Okay? D says interpret the intercept in context. So the intercept is this number. And so for that we say for year 0 or at year 0, this only is from 1990 and above. So, but at year 0, the debt was $2,231,226. That doesn't make much sense, but that's what it is. Make sure you know how to interpret it. For 0, whatever the x is, this is what y would still be. Explain in context what R squared means. This is going to come up on the AP exam. It's just going to happen. Just know how to say it. So 98.8% of the variability in y, so y is debt, in debt is accounted for by the variability or variation in whatever x is, so x happens to be debt year. And then F, you decide to take a look at the residuals plot before making any predictions, and based on the following residuals plot, does linear regression seem appropriate for these data? No. The residuals plot is curved, has a pattern, something. So a linear model is not appropriate. I could see a question like that easily being a free response question. Maybe not so many parts, but it'll ask you to interpret the slope on the y-intercept, and it'll ask you about R squared. It'll ask you to write the equation. So make sure you know how to do all those things. Okay, then we have the free response. A simple random sample of 9 students was selected from a large university. Each of these students reported the number of hours he or she had allocated to studying, the number of hours allocated to work each week. At least squares linear regression was performed, and part of the resulting computer output is shown below. The scatter plot below displays the data that were collected from the 9 students. So we have a computer output and a scatter plot. Create a model to predict hours allocated to studying from hours allocated to work. This time we're using the computer output. So this is for part A. I'm going to do it over here. If we're going to predict hours allocated to studying, we have studying hat, or study hours hat, or study hat, or something. Equals the y-intercept. The y-intercept is the one that says constant next to it. 8.107 plus the slope times x. The slope is the one that has the variable next to it. So plus 0.4919 times work hours, or whatever you want to write that as. Sorry, technical. Because my pen wants to stop working today, obviously. There is the model. That is the answer to part A. Then it says, after point P, labeled on the graph above, was removed from the data. So here is point P, and they got rid of it. It's no longer there. A second linear regression was performed, and the computer output is shown below. Create a model to predict hours allocated to studying from hours allocated to work after point P was removed. So if we can do another one, we have study hours cat equals y-intercept 11.123 plus slope times work and then the question continues. Does point P exercise a large influence on the regression line? Well, let's look at it. Here's our first equation. Here's our second equation. The slope of the line definitely decreases. It goes from 0.49 to 0.15. If you look at the scatter plot, the association becomes weaker. It's no longer so much positive linear because you don't really give a direction with this little smattering of points. If you look at the other things, let's see here, r squared, 47.6, so it's not a great fit. But down here, r squared is only 2.5. That's a terrible fit. All right, so the correct answer for C is yes, it has a large influence. And you could talk about any of those things. Slope, correlation, r squared, all those things change. Okay? You would need to use evidence from these computer outputs. I would use r squared. I would use the slope. Okay? The researcher who conducted the study discovered that the number of hours spent studying reported by the student represented by P was recorded incorrectly. The corrected data point for the student is represented by the letter Q in the scatter plot below. So now P, which was way up here, is moved down here to Q. Explain how the least squares regression line for the corrected data would differ from the least squares regression line for the original data. Well, if you look at this now has a negative association. So you would talk about how you have a negative slope or a negative linear relationship. That Q is definitely going to change the correlation. It's definitely going to change your slope. So you now have a different model, completely different. So you need to say something about that. Okay? So that is your Unit 2 test. Hopefully, I think that's a good indicator. Those questions are a good indicator of what you would see on the AP exam. Computer outputs are going to be all over the place. We talked about Chapter 27 recently, so you should be better with those anyway. You know how to use those equations from the yellow formula sheet. You need to know how to look up things in your calculator. You need to know how to calculate a residual. Okay? All of those things are going to come into play. How to write the sentences. Slope and y-intercept should make sense. It's just based on a line in algebra. If you put 1 in for x, well then for every one change in that, the slope is this. So that means that y changes by that much. So about the y-intercept, that means you put 0 in for x. So for 0 x's, you have this many left for y. You need to know the r squared sentence. Cannot say that enough. It will show up on the AP exam. Okay, so know those.